All right, since I didn't get any questions, today we're going to put together density and conversion factors. Okay? Because we can think of density as a conversion factor. What do I mean by that? Well, I go to the table and I look up the density of aluminum. And I find aluminum's density is 2.7 grams per centimeter cubed. 2.70 grams per centimeter cubed. What does that mean? Well, every time you say per, that means out of 1. Unless you say percent, which means out of 100. So that says 2.70 grams for 1 centimeter cubed. So I could write that this way. Okay. 2.70 grams is 1 centimeter cubed. Hey, those two things are equal to each other. I can make conversion factors out of them. So I can either make a conversion factor that says 2.70 grams for 1 centimeter cubed, or 1 centimeter cubed for 2.70 grams. Because remember, a conversion factor has to have the thing on the top and the thing on the bottom be the same. And 2.70 grams of aluminum is 1 centimeter cubed of aluminum. 1 centimeter cubed of aluminum would be 2.70 grams of aluminum. So they're equal to each other. Where can we use that? Well, you answered questions like this on the density practice. What's the mass of 25 centimeter cubed of aluminum? And the way you did it on the practice, they asked for the mass. They give me centimeters cubed, which is volume. And I know the density is 2.70 grams per centimeter cubed. So if density equals mass over volume, multiply both sides by V, I get that mass is density times volume. And then you plug the numbers in. That's how you would have done it. And that would work. That would get you the right answer. But I want you to look at this problem as a conversion factor problem. If I start off with that 25 centimeters cubed, what unit do I want to get rid of? Well, that would be centimeters cubed. Where would it have to go? On the bottom. What could I turn centimeters cubed into? Well, I could turn centimeters cubed into meters cubed, but that doesn't mean good. What I want is grams, and I can go from centimeters cubed to grams because for aluminum, I know 1 centimeter cubed is going to weigh 2.70 grams. That cancels out my centimeters cubed and leaves me with just grams. And I push the buttons on my calculator. Round to 2 sig figs because 25 centimeters cubed only has 2 sig figs. And I get 68 grams. But notice this is volume and this is density. I did exactly the same math as if I was going to set up the equation, except I didn't have to think about the equation. So it gets the same answer in a different way. And where would you want to do that? Well, you'd want to do that on a question like this. Okay, so you pick up a piece of lead and it weighs 25 kilograms. By the way, that's over 50 pounds. It's a heavy piece of lead. And you go to the book and it tells you that lead has a density of 11.4 grams per milliliter. What is the volume in milliliters? And I give you a bunch of equivalent statements to look at there too. So they gave me kilograms and they want milliliters. Can I get from kilograms to milliliters? Well, kilograms I can turn into grams. And then grams I'll be able to turn into milliliters. Okay. So I start off with the 25 kilograms they gave me. Make my first conversion factor. Get rid of kilograms. What can I turn kilograms into? I can turn kilograms into grams. Which is bigger, a gram or a kilogram? Well, a kilogram is bigger, so it gets the 1. And the gram gets the 1,000. And kilograms have canceled out. Now, what unit do I want to get rid of? Grams. Where's it got to go? On the bottom. What can I turn grams into? Well, I can turn grams into milliliters. Because the density says if I had 1 milliliter, it would weigh 11.4 grams. The grams canceled out, and I've got the unit I wanted. Okay. So I push those buttons. 25 times 1,000 divided by 11.4 equals a whole bunch of numbers. How many do I get to write down? Well, the first 25 kilograms, that's got 2 sig figs. The grams and kilograms, that has unlimited sig figs because they're both metric. Grams to kilograms is definition. Grams and milliliters, well, to get between grams and milliliters, you'd have to measure it. So it's a measurement. That has 3 sig figs. So out of 2 sig figs, unlimited, and 3, what's the smallest number? Well, the smallest number is 2. So I can only have 2 sig figs in my answer. So that would be 2,200 milliliters. Now, if I gave you this on homework, you'd say, oh, before today you would have said that they gave me a density. Oh, my pen decided not to work again. Lovely. They gave me a density, and they wanted a volume. They gave me a mass. Density equals mass over volume. Multiply both sides by volume. So I get mass is density times volume. And then divide both sides by d. And I get that mass over density equals volume. So I should take the mass and divide it by the density. Well, here's the mass. And here's the density. I divided by it. I'm doing the same math. Now if I put 25 kilograms over 11.4 grams per milliliter, that won't give me 2200. But that's because this is grams and this is kilograms. If you're going to do in the equation, you have to fix that first. Okay? Because grams and kilograms don't cancel each other out. So we're doing the same math using conversion factors. We just don't have to take the time to fight and look up the formula. The units set it up for us. I wanted to get rid of grams. It goes on the bottom. I can turn that into milliliters. Okay? So that's the last new piece of information. And traditionally about this time of year, right before the first test, you guys do a density lab where you have to measure stuff and do the math with the right sig figs, showing your work, including the units, figure out percent error, all the pieces we've done along the way. Unfortunately, I can't have you do a density experiment at home, but I got a solution for that in that I've done it for you. And I've done it for you, but you're going to have to read the equipment. So we need to talk about how to read the ruler and the graduated cylinder. Hopefully, you remember that this was our whole idea about sig figs. That looking at this green line, nobody would say it's 4 centimeters long. It looks like it's about 4.5, but if you look carefully, it's a little bit more than 4.5. Looks like it's kind of in the middle of 4.5. And to write in the middle of 4.5, between 4.5 and 4.6, I would write 4.55. Notice that the lines here, that this is 4.0, then it's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So these all have 1 decimal place, but this has 2. You should have 1 more decimal place than there are lines. You should be able to divide the space between the lines into 10 even pieces and estimate where it's at. We require that you that you read between the lines. So the fact that I put a second decimal place here means anytime I use this ruler, I need a second decimal place. Any measurement off this ruler will be something, point, something, something, and that number will be estimated every time. I mean, it may be estimated that it looks like it's right on the line. That's a 0. Okay? But the estimated number is always 1 place further than what shows up on the ruler. So here there are lines at 0.1, so I estimate to the 0.01, the second decimal place, that this is where my estimate's going to be. And I'm required to do it. The bad news is they trust your judgment. Because in the lab today, you're going to see a picture of some pieces that have been measured, and you're going to have to read the numbers off the ruler. Make sure when you read the numbers off the ruler, you put 1 more space than there are lines. That's one of the things I'm checking, because that's what we said we always do. Okay. One of the other things you're going to use is a graduated cylinder. Okay. A graduated cylinder is just a cylinder. Graduated means somebody put lines on it to mark even spacing. That's what graduated means. That somebody put lines on it. So a graduated cylinder, got a smooth cylinder with lines talking about milliliters on the side. And they come in a variety of sizes. I've got 10 milliliter ones. I've got 2 liter ones. They come in bunches of different sizes. So today I picked 100 milliliter ones. So you're going to have to read the graduated cylinders, and there's a technique to that too. First of all, when you put water in the graduated cylinder, it's not going to be flat across the bottom. It always curves on the edges, right? That curve is called a meniscus. Okay. The curve that the water takes because later on we'll learn it's because it's attracted to the glass. So the water is going to touch the sides of the graduated cylinder one spot and then sink down below it. The graduated cylinder is designed so that you measure at the bottom of the meniscus. So it's going to be curved, and you measure at the bottom of it. Not where it touches the glass, where the bottom of the curve is in the middle of the graduated cylinder. So it's going to look more like that. Although this is a little bit exaggerated, but it's going to curve. You'll see the pictures. It curves. So now you have to read what this says. And you're tempted that looks like 34. Oops. Doesn't that look like 34? Looks like 34 to me. But when you zoom in, look at where the bottom of that is. It looks like it's right on 34. It's not up to 35. It's not down to 33. It's right exactly. It may not. It might be just a little bit above it. I'm not sure, but it looks like it's right on the line. And the way I say it's right on the line is by putting, 0.0. That's what that 0.0 means. That means my ruler is marked in my graduated cylinder is marked in the ones place. I need to go one more place. So this is doing exactly the same thing as we did on the ruler. Okay, so because if it had been a little bit above the line, well, actually, let's show what that looks like. Okay, so I measured a different amount of water. You want to look at that. Now, this looks like it's between 21 and 22. It doesn't look like it's right on the line. You know, it goes below 22, but it doesn't look like it reaches all the way down to 21. So I would write 1 point something. Let's look again. It looks like it's pretty close to the top, doesn't it? It's not down towards, it's not 21.1. It's very close. It's pretty close to 22. So that'd be 21 point. Uh, 8, 21.9, 21.7. I'm not real sure, but I know it's not 20. I know it's not 21.1. I know it's more than 21.5. That's what. Am I sure that it's an 8? No, it's an estimated number. We always estimate when we take measurements. So that if you use the same tool, you should always have the same decimal places every time. So every time I use this graduated cylinder, I need one decimal place, even if I have to write 34.0. I have to put that 0.0 in. Okay? Because I lose information if I don't. So That is how you're going to read the equipment. Give me a second here. So what are you going to read? Give me a second here. I had it open and it left on me.